Exponent rules for division has two different rules that we need to follow. The first one we just call the division rule. The second one is a power of a fraction rule. We'll start with this one. So when dividing two terms with the same base, so like terms, so a and a are the same base, we can subtract their exponents. So I would take x and subtract it from y, giving me a to the x minus y. So in other words, when dividing like terms, subtract their exponents in the numerator, and then simplify. So let's look at a few examples of this below. I'm going to first show us why this makes sense using expansion. So 3 to the 5th is the same as 3 times 3 times 3 times 3 times 3 over 3 to the 2nd. So for each 3 in the numerator, I can cross out a 3 in the denominator. This leaves me with 3 3's in the numerator, so that would be 3 to the 3rd. If we'd used the rule, we would have taken 3 to the 5th and subtracted 2, and we would have still gotten 3 to the 3rd. For the next example, we're going to expand again. So I write the 2 5 times. And I write the x 7 times. And then the denominator, I write the 2 2 times and the x 3 times. Again, for each of the same numbers in the numerator and denominator, you can cross them out. So 2 and 2. That leaves us with 2 to the 3rd power. And then for our x's, we'll cross these out. And that leaves us with 1, 2, 3, 4, x to the 4th. So that's how you'd solve using expansion. If you wanted to use the rules, you would do 2 to the 5th, take away 2, 5 minus 2, and x to the 7th, take away 3. 2 to the 5th, take away 2 is 2 to the 3rd. 7 take away 3 is 4. So again, we would have had the same answer by solving it either way. In example 3, we see a negative exponent. So everything is the same as example 2. The 2 to the 5th, the x to the 7th, the 2 to the 2nd, but we have x to the negative 3. So I'm not going to do the 2's again. We already know that it's 2 to the 3rd, but I want to focus on the x to the negative 3. So there's two ways of thinking about this. If we were to move x to the 3rd to the numerator with x to the 7th, we would then simplify the exponent because it would become positive, and then we could add 7 and 3 and we would get 10. So it would be 2 to the 3rd x to the 10th, and that would be our final answer. If you wanted to use the rule, so we already know we have 2 to the 3rd, we could take 7 and subtract negative 3 from it. 2 negatives make a positive. 7 plus 3 is 10. So again, you'd get the exact same answer. Number 4, same as number 2 and 3, but now the 7 is negative and the 3 is back to being positive. So again, we know that the 2 is simplified to 2 to the 3rd. So the last problem, we had to move the x to the negative 3 to the numerator to make the exponent positive. Now we're going to take x to the negative 7th and move it to the denominator to make that positive. So we're going to be left with x to the 3rd and x to the positive 7th now. Once again, these both have the same base, therefore we can add their exponents, and that would give us 2 to the 3rd over x to the 10th. Power of a fraction rule states that if there is a term in parentheses to an exponent, you're going to give that exponent or distribute that exponent to each one. So pretend there's a 1 next to a and a 1 next to b, x times 1 is x times 1 is x again. So when a fraction is in parentheses to a power, give the power to the numerator and the denominator. Oh, and I forgot to fill this in. Always make sure exponents are not negative or 0. And that's what we covered already. So, example number 5. We're going to pretend that the 2 and the 3 have a power of 1. They technically do, it's just not written. So 2 times 1, or I'm sorry, let's do expansion first. I'm going to write 2 to the third, or I'm sorry, 2/3 twice. So if I were to multiply across, that would give me 2 squared and 3 squared. And that's how we'd solve using expansion. Or we could give the exponent and multiply it to each of the exponents in the numerator and the denominator. 2 times 1 is 2, and 2 times 1 is 2 again, giving us the same answer. For example 6, we will solve this using expansion first. If we multiply across, the 2's can be rewritten as 2 squared. The x's can be rewritten as x squared, and the y's as y squared. If we wanted to use the rule, we would multiply 2 to the powers and get 2 to the 2, x to the 2, and y to the 2, which is the answer we already have. Remember when there are numbers and variables or multiple variables next to each other that you need to give the exponent to each one of them, not just the x or not just the 2, but to both. In example 7, we are now going to deal with negative exponents. So for this, we know that it simplifies to 2 to the second and 3 to the second. But now it's negative, so it's 2 to the negative second power and 3 to the negative second power, because if we multiplied, negative 2 times 1 is negative 2 for both bottom and top. We can't have negative exponents. So we can split them into 2 separate fractions like we've done before, but I think we know how to do that, so I'm going to do this the quick way. I know that to make this positive, I would move it to the numerator, and to make this positive, I would move it to the denominator, giving me 3 to the positive power of 2 over 2 to the positive power of 2. Same with example 8. We know that it's going to be 2 squared x squared over y squared, but it's just going to be negative now. And again, because all of them are negative, they're all going to move. So I'm going to move both of these to the denominator and the y to the numerator, giving me y squared over 2 squared x squared.